position, positive, negative, or zero? Yeah, I'm on the plus side of my origin. My position now, and my position now, yeah. All right. That's the plus minus zero. Everyone's giving the correct answer simultaneously would be really cool. You know, in physics sense. Displacement is where an object is with respect to the starting point. We're talking overall displacement. So the overall displacement is positive if on the positive side of the starting point. So I am going to make, that's my starting point. I have to use the same convention, positive is still to the right. So right now, again, assuming that's my starting point, my position, slowly trickling through there. My displacement,
Positive.
there we go, that's sounding much better. So you can get more voices. All right, my position now,
Negative.
my origin's still there. My position, my displacement, yes. I'm on the negative side of the starting point, I'm on the positive side of the origin. I have positive position, negative displacement. My position
Negative.
and displacement,
Negative.
all right. Velocity. The symbol for velocity
V.
with a vector symbol over it. It is how fast an object moves and in what direction. Or it's the time rate of change of position. Either one.
Could that be written as T delta pause?
Where are you looking?
T rate of change of position, T for time, rate of change delta of position. I usually write that as POS, pause.
Oh, you want to abbreviate position as POS? Is that what?
Yes?
Sure. Okay.
Okay, but what about the first two characters, which are significantly more important?
All right, I think we're out of sync here. Start again. What is your question?
Time, okay?
Yep.
I abbreviate that as T.
Okay.
Rate of change, I abbreviate that as delta. Position, I abbreviate that as pause. Would it be coherent or acceptable for you if I wrote it that way?
Well, let me do you one better. The second one, as you're sort of indicating, does lend itself nicely to a formula. So here's a formula. Velocity is the change in position over the change in time.
Cool, thanks.
Now there are two types of velocity. There's average and there's instantaneous. By default, if I just say what is the velocity, I'm asking for the instantaneous. If I want the average velocity, I will have to specify average. This is default. Technically, this is a formula for average velocity. Who in here has had calculus, or in Calc 1 at least? Okay. This is a side note, this is not within the scope of the course, however, for some of you, velocity by definition, the XCT. If you don't know what that means, don't worry about it.
Distance?
Pardon?
Distance? D?
No, the D in front indicates you're doing a derivative. You're
Oh,
finding
okay.
the slope of a line that's tangent to a curve. When you take Calc 1, you'll go,
I'll
oh,
understand
of
that
course.
eventually, okay.
Yep. It's like the delta, except for infinitesimally small changes in time.
Okay.
So, I'm in a race with Usain Bolt. I'm going around a track. So Usain Bolt, me. We go around the track, Usain Bolt goes all the way around in 40 seconds, and I go around in 240 seconds. We start and end at the exact same spot. Who has the greater average velocity? How'd you get that? What's the formula for average velocity?
I mean, with the formula that you just wrote on the board, D,
Yeah.
delta x vector over delta t.
All right,
He
so what
went
was our?
faster, so he had less time. So even though the x is pretty much the same,
What is the delta x?
the delta x,
It's change in position. What was our change in position for the race?
displacement is 0 because you started and ended at the same point.
Yeah. Displacement is 0. So what is his average velocity?
0.
What is my average velocity?
Also 0.
I'm as fast as Usain Bolt. Now, at any point along the path, if I ask for the instantaneous velocity, well, yeah. I think most people would say he was faster. Let's take it one step further. By the time Usain Bolt finishes, he's here. We've just established his average velocity is 0. I'm here. Is my average velocity 0?
No.
I'm faster than Usain Bolt. Physics makes us faster. Or warped, one or the other. Now, if I was talking instantaneous is, at this point right here, where was I compared to where I am now? How long did that take? And so then you start getting into the more common definitions. Speed, he's definitely faster at greater speed than I am because we went the same distance and he did it in less time, but our displacements were 0 overall.
How do you do the instantaneous formula for velocity again?
All right, so if you look at the formula there for velocity, it's the change in the position over change in time. So if I had a position versus time graph, yeah, no, this is the previous class.
Oh, I'm like, when I'm late. My fault, though.
You're early. Yeah, I know, we're running out of time here. Some people are just dying to get in here. All right, so if I did a plot of position versus time, and it looks like this. If I wanted to figure out what is my average, so at this point right here, that's when I stop. If I want to figure out my average velocity, I look at my change in position over the change in time. In essence, I'm finding the slope of that line right there. Change in the vertical, or rise over run. If I want to find the instantaneous at this point right here, I would draw a line that just barely touches, so it's a tangent line. And I find the slope of that tangent line. And that's how you find instantaneous.
So instantaneous is like drawing and you're trying to, and you zoom in real close so you can have every pixel just right.
Yeah.
Okay.
Pretty much. Officially, it's it's known as that the XDT is the limit as delta t goes to 0 of delta x over delta t. That, and I think in pre-calculus you do limits. No? Okay. I think we're past time, and we're probably someone else that can get into the class way early. Lab, please print out the lab for tomorrow, and don't forget the course entry assignment.
Assume Jonathan is not joining us. Find the way. Nice to finally have notes to read. All right. It should be under start here. There should be somewhere in there linked to. It's always a matter of what did I do wrong.
Go up to how to begin.
Mr. Fox, Dr. Fox, do you have any dress requirements for lab days, like
No.
no swooshy skirts or something?
No, there's no. Yeah.
And I'm guessing, I think the only thing you wouldn't have against is then food.
There's not inherently anything wrong with having food or drink in there, but you clean up your mess.
Okay, so you're not gonna be like a high school teacher, like, you will die if you get food in this water.
No.
Cool.
Oop, forgot to stop that.